I'm just going to repeat what I said a couple minutes ago. Really great to see a bunch of different faces. If you could, just put in the chat box where you're from. It's actually cool to see that we have a lot of people not from Denver. We're making the world a little bit smaller, as I believe it was Krishna pointed out. And if you are willing, turn your cameras on. If not, that's totally okay. But I think this is the closest thing that we can do to the in-person meetups and actually see everyone's faces. I'm personally looking forward to getting back to the in-person meetups. I hope we can do that towards the end of the year. Obviously, no one knows quite yet, and we'll keep safety first. But for now, it's really good to be able to open this up really to the entire world. So let's go ahead and get started. This is the Denver MuleSoft Meetup group. I am Aaron Lieberman, and we're going to talk about never losing data again and really best practices with integrations with MuleSoft. Kind of already went through, you actually sort of know what the agenda is. Obviously, we're going to be presenting on the subject I just talked about. And so just to introduce myself a little bit more, again, Aaron Lieberman from Big Compass. I'm an architect at Big Compass and the Cloud Practice Manager. And so, what I'm passionate about and what I love talking about is kind of all things cloud. So the meetups that I'm a part of, I want to talk about what's going on in the cloud and, deploying the Cloud Hub, interfacing with AWS, interfacing with Azure, between MuleSoft, because I truly think the combination is very potent and it's very prevalent with many of our clients. Big Compass is a small IT consulting company based here in Denver, Colorado, and I'm one of the organizers of the Denver MuleSoft Meetup group, along with Linda Gunn. And what we had set out to do, a little over a year ago now, is just really bring the community together. There wasn't a Denver MuleSoft Meetup group yet in Denver, and we just wanted to see kind of what's out there, and so far it's been really, really good. The turnout at in-person meetups has been awesome. We've got to meet quite a few MuleSoft employees and just also MuleSoft users and customers who are in the community. There's actually more than I would have thought. So great to meet all of you who are on the call who are not from Denver, and hopefully we continue to share these experiences. If you're interested in any of the content, I always post the content after the meetups, and I'll blast that out to everyone who RSVP'd. We are recording the conversation, so just a heads up, and I will post that on YouTube as well as share the slides with everyone. If you ever have any questions about any of the content, feel free to reach out to me. It's aaron@bigcompass.com. Feel free to go to the Big Compass website and reach out to any contact info we have on the Big Compass website. And just two more quick introductions, just housekeeping items. Brian Statkevichus is on the call, and Brian is going to be one of the newest organizers for the Denver MuleSoft Meetup group. Brian has a wealth of knowledge with integrations as well as MuleSoft. So I just want to introduce Brian. Brian, do you want to come off mute and say anything?
Sure. Thanks for the introduction, Aaron. For those of you who are in Denver, I did present at the February meetup that was about Flow Designer. And as Aaron mentioned, he's going to be gradually transitioning his responsibilities over to me. The next meetup will be the same. He and I will be jointly running it. And gradually, I will have to fill Aaron's very big shoes. He's done a fantastic job with this meetup. And I'm looking forward to keeping it going. Thank goodness I'll also have Linda helping me out because I definitely need it.
Absolutely, and I'll still be a heavy participant. I'll still kind of help in the background to organize. I'll still probably even present here and there. But Brian's going to take over, the majority of the responsibility of organizing the Denver Meetup group, as he said. And then the other introduction I wanted to do is Stephanie Lawrence, who we have here on the call. Stephanie's going to be heavily attending our events and sort of start to help coordinate these events. Stephanie, is there anything you wanted to say?
Yeah, thanks, Aaron. Hello, everyone. I'm just really excited to just jump onto the Big Compass team within the past couple days, and you will see a lot of me in the next couple months. So I'm excited to meet every one of you, and thank you for being at the meetup tonight.
All right, and hopefully last housekeeping item, if you could, for the virtual meetup, stay on mute as much as you can. I'm going to be open to questions. I'm probably going to pause just a couple of times throughout the presentation. So put questions in the chat box, and then I'll pause at a couple key locations throughout the presentation, and then we can take Q&A afterwards also. And Linda will be helping me, just to, if anyone comes off of mute and is making noise or anything like that, Linda will be helping me make this go smoothly. All right, so let's talk about what we're here to talk about. And that's MuleSoft integration best practices. And I don't want this to be a presentation where it sounds like I know all of this, the best practices, because I certainly don't. I would love to hear from all of you. I like this to be interactive. It's a little bit hard to do that virtually, but like I said, put any comments and questions in the chat box. And I would love to learn as a community here. And that's really what the point of the meetup is. So integration best practices, kind of what that means to me is quite a few things, right? But we're going to do our best to get through some of the main pieces of content as it relates to integration best practices. So what that means to me is asynchronous and synchronous considerations. When would you use asynchronous versus synchronous? Caching and queuing and decoupling application components into microservices and throttling those different microservices. And of course, no system is complete without logging and monitoring. And just before we get into that, so why would we even talk about integration best practices, right? So integration is something that's been around for so long, and integration still comes with some major pain points. 7 of these pain points are listed on the screen, and I would like to just take this opportunity for everyone to read through these pain points. And if you have other pain points with your integrations, can you put them in a chat box right now? I'm sure there's at least 2 times this out there. And this is exactly why we talk about integration best practices. We talk about integration best practices because there's still pain points. Over the decades that integrations have been around, we're still dealing with some of the recurring pain points. So that's what this presentation is all about. We want to enhance system visibility. We want to enhance system traceability. You need to be able to support your integrations. One of the things that I see with most of the clients I work with is that support cost is one of the highest costs that are out there. Message loss, we're going to talk about that pretty heavily today. You never want to lose messages in your integration system. Scaling your integrations, high availability, and the flexibility to be able, and what I mean by flexibility is not scalability. Flexibility is to be able to replace application components through good decoupling and configuration-driven approach to be able to replace the components as technology changes, as algorithms change, as security changes and things like that. So that's why we're here to talk about integration best practices today. Let's get into a giveaway. This is more like a quiz question. I'm going to do my best to work with MuleSoft to do what we actually do at the in-person meetups. So for anyone who can answer this, just first person who gets it right in the chat box, we're going to do our best to get you an exam certification voucher. So does anyone know the difference between asynchronous and synchronous executions? I'll give it a minute to fill out the chat box here. Thread and same thread. Yeah, I think Sridhar, that's real time versus not real time, blocking versus non-blocking. Yep. So we're actually going to answer that here on the next slide. I think most people are hinting at it. So let's talk about when would you use asynchronous executions and when would you use synchronous executions. But first, let's just define what those are for anyone who's coming in, completely fresh and might not know what that is. So asynchronous invocations, to me, means you do not wait for a workload to finish processing. Just like some people put in the chat box, it's fire and forget, it's non-blocking is what I would use as synonyms for asynchronous invocations. For synchronous invocations, you would wait for the workload to finish processing. So it's kind of finish and move on, it's blocking, you would do something, wait for it to finish, and then move on only once that thing is finished. I really like the infograph at the bottom of the slide here. If you're not familiar with synchronous versus asynchronous, I think this tells the whole story, where synchronous, if you have 4 steps in a process, step 2 would only start after step 1 completes. Step 3 would only start after step 2 completes, and step 4 would start only after step 3 completes. But with asynchronous, you can see that Step 1 can be running at the same time as 2, at the same time as 3, and in parallel to step 4. Asynchronous really means that multiple threads are running at the same time, and you can invoke those without having to wait for them to finish. But as we know, there's considerations with synchronous and asynchronous. So let's dive into synchronous a little bit more. So synchronous, as we just defined, is waiting for the workload to finish processing. And how could you actually invoke synchronously? A lot of us probably know that as GET requests. It's going to be the API request and response. As we know probably so well with MuleSoft, we interact with APIs almost all the time. You can also invoke via SDK and wait for a response. So there's about 1 million SDKs out there. Today, MuleSoft even has an SDK now. You know, if you're using AWS's SDK, you can invoke Lambdas synchronously and wait for them to finish and get a response. So SDK is another great way to invoke synchronously. You can invoke a connector and wait for it to finish, and you can invoke a flow and wait for it to finish. And when you would actually invoke synchronously would be really taking the step back and say, okay, when is synchronous right for me and when is asynchronous right for me? So synchronous would be right when you have GET requests that require data to be returned right away, and you're going to do something with that response. So that response is potentially enriching something in your process, and you need that data before you can actually move on to next steps in your process. And if you want really quick responses, also if you just have quick responses. So for example, if it's a very, very simple lookup, let's say in a database, and you have a very quick response, it probably doesn't make a whole lot of sense if that's already pretty optimized to make that invocation asynchronous, because asynchronous a lot of times has to do with optimization and processing time and latency. But if you already have a quick response, you just get that synchronously and then just move on. When it's not a good idea to invoke synchronously is when you have workloads that can process in the background. So if you ever can kind of offload something to just process in the background, totally non-blocking of whatever process that you have running, it's probably a good idea to invoke that asynchronously. And then any really long-running processes. I think we've all probably invoked APIs that take forever to give a response, and whether it's systematic or you're actually hitting an endpoint via Postman, and you're just waiting there and waiting there and waiting there, or your system, even worse, can be waiting there and waiting there and waiting there, and then eventually run into a timeout, which can cause problems for your system and run into error handling and all of that type of thing. So when you have a really long running process and you can offload that to run in parallel and in the background, probably a good idea to run asynchronously. So the benefits of synchronous would be that you can know right away if something succeeded or failed. This is the classic Postman GET request example. You get Pokemon, in the demo that I'm going to show, you get those Pokemon details, and right away you know if that succeeded or failed, and right away you have your response. So you can respond to clients also right away, so they don't have to look up results later. And we'll compare and contrast that with asynchronous in just a little bit. So I'm going to kind of zoom in on the demo architecture today and just talk about synchronous invocations here for a second, where we're going to continue along with the getting Pokemon information from an API. And for those of you that aren't familiar with Pokemon, it's something that we've done here in the Denver MuleSoft meetup. It just started, when we first started out with this meetup group, and we just have these APIs that have kind of continued to evolve to get Pokemon abilities and to start to insert and upsert Pokemon abilities, which we'll see today. And Pokemon, if you're not familiar with them, are these creatures that kind of have special powers and fight against each other. So just kind of a silly thing that we do at the Denver MuleSoft meetup group. The synchronous flow, though, is when a client is going to make a request to our Experience Pokemon API. And what we're going to do directly behind that is set a transaction ID for the entire transaction. Just going to be a 36-character unique ID. And then we're going to say, is this a synchronous request or not? And the way that we're determining that is, for the purposes of this demo, we're just going to say all GET requests are synchronous requests, and all post and put requests are asynchronous requests. So if we say that there's a synchronous request, what we're going to do is make a request to the Pokemon system API to actually get that Pokemon information. And then once we have that Pokemon information, we can respond back to the client with the transaction ID, and we can log. So closed loop, you know, there's nothing that we're waiting for here. It's kind of the classic GET request. And then zooming out now on the entire system, we'll dive into each one of these parts a little bit later, but just so you know what's going on and talking about this just a tiny bit more right now, is if it's a synchronous request, kind of in the bottom right of the red box in the top left, you're going to see that it's making a request out to the Pokemon system API. And that system API, all it's responsible for is sitting in front of a database full of Pokemon information, and it will get the necessary Pokemon information and do some logging, which we'll take a look at later. And if you look in the bottom right-hand corner, the yellow box, what we're doing is we're logging from our distributed applications here out to one application, which will handle all of our logging needs across the distributed microservices here. So we're kind of completing all of the topics and subjects with these kind of three applications making up our system for today's demo. So let's demo the Synchronous API. It's going to be a pretty quick demo, and you can probably imagine already what this looks like. But what I'm going to do here is just get some information for Pikachu. And you know, notice how long this is taking, right? It's usually between 2 and 3 seconds for the latency of this API. Okay, so I've got my information here for Pikachu. I know that Pikachu is an electric type Pokemon, and he weighs about 60, has a height of about 4, and I have this transaction ID, which I can look up later. I can do the same thing for Mew. I've learned a bunch of different Pokemon going through this, which is always fun. There's a Mewtwo. So you kind of get it, right? We're making synchronous requests, meaning that the whole process is a closed loop, right? I don't have to go back and look up this information after the fact. And just to show the code really fast, what's going to happen to power that is, you can see here, just starting at the top, we're using a simple RAML API spec. Right, and we have 3 endpoints, and so we were able to scaffold those out using the API kit router. And our endpoints are going to live at the bottom of the flow here. So you can see that this get endpoint, which we're going to focus on now, we'll move on to post a little bit later. This get endpoint, all it does is it sets up some variables, which is this flow here, setting a transaction ID basically, and then it will get the Pokemon. And all this is doing, kind of a neat little trick, because we're doing some logging, we're doing some caching, which we're going to talk about in a minute. But then it calls out to this flow, and basically what it does is it checks our database for any Pokemon information, and if that Pokemon information exists, we're going to return it. And I've populated our database with a bunch of different Pokemon information, so we can hammer that database really as hard as we want. So that's the synchronous closed loop. And again, just a reminder, put any questions in the chat, and I'll probably pause here in about 5 minutes. Back to the presentation. So what goes along with synchronous invocations is caching many times. So what is caching? Caching is when you maintain a frequently accessed data in memory or in an external store. With MuleSoft, they've come out with Object Store V2, which is relatively new and built to handle a pretty large scale. And it's made for quick access to your objects, right? So this would eliminate, for example, going out to a database and storing and housing that information either in memory or in an object store V2, for example, with MuleSoft in this case, and having quick access to that information. So the ways that you can cache in MuleSoft, number one is API Manager. You can have a caching policy on your APIs if you register them with API Manager, which I would highly suggest. And then number 2 is a caching scope. And you just actually saw the caching scope in my flow there. And the caching scope is basically going to allow you to define what the request payload is going to be, and then it will store that information in the cache within your application. When would you actually cache? So this is really what you want to be careful with. So you kind of only want to cache in some certain scenarios. Number 1 would be frequently accessed data. If you can take some utilization off of applications by caching frequently accessed data, by all means, you should do that. GET requests are a very common candidate for when to cache data as well. Most often, GET requests are going to be getting information, from a database or from a system that potentially you can cache if those responses are static, which is number 3 here. Overworked resources are also a great candidate for that. So if you see that you have APIs with GET endpoints in your APIs, and those APIs are overworked and you're starting to need to scale those up or out, you can look at those overworked resources and say, hey, do I have any opportunities to actually cache my data here? And so I don't have to go out to that target system or that target database as often. And when it's not a good idea to cache is when you have updates that are frequently made to resources. If you, for example, change an object in a database, but you're actually caching that for, let's say, 30 minutes, that change wouldn't then be reflected in your GET API requests until your cache actually expired 30 minutes later. So you have to be aware of that. And the benefits of caching are huge when it's a good candidate for caching, which we'll take a look at here in a second. You get faster responses, better UX. If you're building a front-end application on top of MuleSoft APIs or a web and mobile application on top of MuleSoft APIs, your users are going to see responses very, very quickly if you're using a caching layer. Less strain on downstream systems. So if you, for example, know that you're going to make 1,000 requests to your database for all of your 1,000 interfaces that run through your system, and you're going to do that once a minute, but those interface details don't change very much, probably a good candidate to cache, because then you only have to reach out to your database for as long as those objects can stay in memory, or with MuleSoft in Object Store v2. And you can hide network failures too. So let's say your database goes down. This is actually a great use case for caching, and it's often missed too. So your database can go down for the entire life of your cached objects. So think about that. Those are great benefits of caching and great use cases for caching. How does caching actually work? So when you begin processing, what you do is you point MuleSoft to a particular part of your message, and it can be the payload or something else. And what will happen is it'll create a cache key. And basically it'll hash that key, and it'll try to look up based on that key in the cache data store. And if the object exists, it will go to the bottom left here and just continue processing because it already has that object in the cache. But if you go to the right and the object does not exist, it has to do 2 extra steps. So think about that in terms of processing. It has to, number 1, insert into the cache. And number 2, it has to interact with that target system that you were going to interact with in the first place. Okay, so let's demo caching. So caching, if I make a request now, let's do this for a different Pokemon because those responses would have already been cached. And just to make the point again, getting information for Snorlax took just under 2 seconds here, okay? But if I send this request now again, now we're going to see 100 millisecond, sub 100 millisecond responses because what's happening is Snorlax now is cached in my object store v2, which I'll show you how to do that in just 1 second. And all my MuleSoft application has to do is create the cache key, recognize that the cache key is already in the data store, and then boom, return that object right back to the caller. So there's 2 ways to cache. Number 1, we saw here, this would be the caching scope. So let's dive into that. The caching scope, if you use the default caching strategy, I've done the default caching strategy many, many times, but just to show what's possible is I created a custom caching strategy here. And what you can do is you can, by default, use the payload to create that cache key and look up the cache in your object store, or you can use a key expression. And so in this case, what I want to do is use my request path. So when I'm making a request to /Snorlax, it knows that /Snorlax is, or /Pikachu is doing the same thing. So when I make 2 consecutive requests for /Pikachu, it knows to go get that in my cache.
Hey, Aaron, we do have 3 questions in the chat.
Great. I am approaching the end of the synchronous topic in just 1 second.
Okay.
And I'll answer those in just a second. And then the second way to cache is now in API Manager. And so let's crack open our Pokemon API in API Manager. And we're going to see a couple policies here. Most notably, HTTP caching. Very, very easy to set up both of these methods of caching. So if you look at what I'm doing here, again, I'm looking at the request path. So /Snorlax would be recognized, and that would persist to my cache. And I have a time to live here of 1 hour and a maximum entries of 1,000 entries, which would be more Pokemon than I would ever make requests for. And this can go up to tens of thousands of entries in your cache for Object Store v2. And I'm only doing this for my GET requests. If you notice that here, sort of at the bottom, only for my GET requests and my head requests, but I don't actually have any head requests. So very, very easy to set up. I would encourage everyone to go look at their GET API endpoints and see if you have any candidates for caching, because the caching scope is so easy to set up and you get such great benefit as well as this policy here in API Manager. So let's take a look at the chat. Linda, have you been inventorying the questions, or should I scroll back up?
It's the last 3 are all questions.
Okay.
Oh, actually, there's 4. There's 4. Another one.
From Akshay. If we were using Cloud Hub deployment, where is data stored for Object Store v2? Yeah, so Object Store v2 is kind of centralized across your cluster, Akshay. And so Object Store v2, and let me just show that really fast. You have an option to be able to use Object Store v2 here. Right here in Runtime Manager by checking this checkbox. And so when you check this checkbox, now Object Store v2 is sort of centralized and decoupled from your applications. So it's stored totally in the cloud. You don't have to worry about management or storage in Object Store v2 because it's totally managed on the back end. So hopefully that helps answer your question. Okay, got a few more. Let's see. Is it in Runtime Manager memory or outside of it?
Oh, it actually, if you go up further, Aaron, because there have been more added, the next one was how long does data get stored in the cache?
Yeah, so how long does data get stored in the cache? That's totally up to you. And so back to the policy here. What you can do is this time to live here in seconds dictates how long an object will actually remain in your cache. So what I'm doing here is specifying 1 hour for those objects to stay in my cache. And then, was there a third, Linda?
There's like a couple more. In cluster on-premise environment is the next one.
Okay, in cluster and on-premise environment, how the cache data is replicated across the nodes. Not possible. What is the best approach to do this? So there's many different methods that you can use here. And actually, I don't know if Object Store v2 is available on-prem or not. Does anyone here know the answer to that question? You can speak up.
Aaron, Object Store is limited to Cloud Hub.
Okay, thank you.
Heard.
So
if you're on premise, you would generally you have access to your whole full file system, so you'd probably use that as your store.
Exactly. So there's going to be shared resources when you have an on-prem clustered environment. And when you have an on-prem clustered environment, now you can start to think about these external caching systems. So one would be, you could use AWS, you could use DynamoDB. There's a bunch of different caching systems that you can hook into, as well as file systems, just like Brian said, to be able to persist that across your clustered environment on-prem. So let's move on with the presentation and continue with questions later. Great questions, keep them coming. Okay, moving on to asynchronous. So diving into async, again, async is not waiting for a workload to finish processing. And so if I were to compare this to waiting on hold with Verizon, asynchronous might be you press 1 to get a call back later, right? You can go about your day, wait for Verizon to call you back, but it's still happening in the background. You're still in the queue in the background. Whereas synchronous maybe is you're waiting on hold until Verizon is actually available. Ways to invoke asynchronously. is utilizing queues and topics. This is the #1 way that I've seen as an integration best practice, and it gives you a slew of other benefits when you use queues as checkpoints in your system. You can fire and forget, and you can use the async scope with MuleSoft as well. When to invoke asynchronously. So we sort of already contrasted this with synchronous invocations, but post, put, delete API requests not requiring data to be turned are a great candidate for asynchronous invocations. And the response is not required before moving on. So for example, let's say you have an error handling framework. And that error handling framework is responsible for catching all errors and sending out alerts to a target system. You don't need to wait for that exception handling framework to complete, right? You can event those exceptions out to something that solely is responsible for handling exception handling. And you can, by putting in integration best practices, ensure that those alerts are going to go out to the target system. And then additionally, slower processes that can run in the background. So these might be your large batch processes, that you don't want to wait for, and you don't want to keep clients waiting for those API responses to be returned. When it's not a good idea to invoke asynchronously is when clients expect an immediate response. So think about maybe a web or mobile application trying to display data. It's kind of those GET requests, or very short running processes. If you're already very, very optimized and it's a very quick request with low latency, you might just return that synchronously. The benefits of async can be pretty substantial. It allows the system to process high volumes of data in parallel. So you can start to use parallelism a little bit more intelligently. And you can utilize your application's horsepower potentially more effectively. So let's say you have an application running in Cloud Hub on 0.2 vCores, but you're only using, in terms of memory and CPU, let's just say 20% of the memory and CPU. Once you start to run in parallel and kick up more threads on that application, you're using those resources on that application more intelligently as you start to spin up more threads and invoke these processes asynchronously. So asynchronous data flow. So we're going to move from the left to the right here. And we've already talked about the client making the request to the experience API, and we're going to determine if it's a synchronous request or not. So we're going to assume that this is a post or put request. And when it's a post or put request, it is asynchronous. When it's asynchronous, what we're doing is using a queue in between our experience API and our system API to, #1, decouple those applications, which we'll talk about later, but first and foremost, to make those requests asynchronous. So we can event out to that queue and then immediately return a response with a transaction ID and log that transaction. And what we can do is, basically what we're saying back to the client is, okay, we have your request and we're guaranteeing that it's going to go to the target system, in this case, into the database. And on the right-hand side here, this application is going to receive that SQS message. It's going to insert that into the database, and it's going to do some logging. It doesn't have to worry about a response or anything like that, because it knows that the upstream application, the Experience API, has already responded to the client, and all it needs to be responsible for is inserting into the database. So let's demo the asynchronous API. We're going to go to the post request here, and I'm going to become a Pokemon. So this is me, Aaron. My ability is MuleSoft. I think most Pokemon probably have more abilities than this, but we're going to leave it at that for now. And apparently I'm very short and very wide. Well, let's go ahead and send that. And what's going to happen here is we're going to get, notice the status, we're going to get a 202 accepted. And if you read the description there on Postman, what that means is the request has been accepted for processing. So that's the correct HTTP status code, essentially for asynchronous responses. So what we're saying back to me, in this case, the client, is we're saying we've accepted your request and we're going to persist that to the database. It may not happen right away, but it's going to happen. And I have my transaction ID here, which I can use to look up what actually occurred in the system at a later point in time. We'll talk about that in a little bit. I'm going to cheat here for now and go into my SQL database. And I can see here that Aaron has been inserted. So it's pretty quick. it probably happens within a matter of about a second or two, which we can look at that latency later. But it's very, very quick. But I didn't need to actually wait to insert that information before returning a response to the client. Okay, and asynchronous flow is going to occur on our post flow here. So when we get a post, what you can see here is we're going to set up the same variables as we did with the get request, and then we're going to invoke the post Pokemon flow. And post Pokemon, this is going to look very, very simple. Okay, all we're doing is some logging, and we log out to our distributed application, which I'll talk about later. We transform the request to go to the SQS queue, which lives in AWS, by the way. If anyone's not familiar with SQS, happy to talk about that later. And it sends out this message to this queue to go be processed on the downstream side of this, which in this case is our system API, which is this application. Very, very simple setup here. All we've done on this application is basically create two different types of inbound endpoints. One inbound endpoint is from AWS SQS, our queue, and then the other one is from get, post, and put API requests. Our queue inbound endpoint, what it does is it receives those messages from the queue, asynchronous, so totally decoupled from the upstream API. And all it's going to do is call our post Pokemon flow again, and it's going to do the exact same thing as if a post request were to come in. And when the post request comes in, I'm sure you guessed it, all this does is it inserts into our database that Pokemon information and does some logging. Okay, so that's asynchronous. I want to pause again. Are there any asynchronous questions? Linda, have you seen any?
The last question that where it landed was, is it mandatory to define in the policy and in the implementation? But from Omar, that question.
Is what mandatory? Did they specify?
No.
Okay.
I think he was asking, Aaron, if you define the cache in your API policy. So the question is, you have to define it both there and in the actual MuleSoft application in your flow.
Great point. I should actually talk about the differences between those two. And one of the major differences, if you implement the cache policy on your API, is that request will never actually invoke your flow. So that policy sort of, you can imagine it sits in front of your API and will return that response without ever getting to your application. So you have to kind of be ready for that. And if you're okay with not logging that transaction, then that's a great policy to implement for you, because it'll never even invoke your flow. But if you want to come in and kind of do some logging and for your flow to control what actually happens, then you want to implement the cache scope. I implemented both for this demo. Both are almost never needed. I would say I can't think of a scenario where both would ever be needed. So hopefully that helps clear that out. Can you invalidate the cache programmatically? I believe you can, although I've never done it. I would have to look that up.
So Aaron, somebody did go into more details on the chat on how to do exactly that. So
there was one too about any best practices for scaling systems that might see more than 10 transactions per second.
Yeah, the question there is that object store seems to have a limit of 10 transactions a second. So that was the question about best practices.
Yeah, so I would think about your cache as something that builds up over time, right? So the more data that you have in the cache, probably the more valuable that it is. So even if you have 10 requests per second, what's going to happen is that valuable data is going to build up in your cache. And what you can do is implement some error handling around your cache responses as well. So the more data you have in your cache, I think the more valuable it is. But then also, build in error handling and be able to prepare for that. So if your cache lookup is declined or errors out, be prepared to go out to your target system.
The only other one is from Gopinath that asks, when we use cache, do we have an option to choose the destination to store in shared memory, or do we use the object store to store it?
I'm looking for that one. Can you read it one more time, Linda?
Yeah, it's from Govinath. It's when we use cache, do we have an option to choose the destination to store in shared memory, or we use the object store to store it?
By default, it would be the object store. Okay.
Yeah, by default object store, can we have an option to store it to a different store other than object store? Like for example, if I wanted to store in Redis, can I choose an option to store it in Redis, or is it only option?
Yeah, absolutely. So once you get into those types of considerations, you're sort of home rolling your own cache. And so you won't be able to use, Mule kind of out of the box caching in that case. So let's say you want to go to DynamoDB and you have a DAX accelerator in front of DynamoDB, which is kind of, it gives you sub 10 millisecond responses. You would be interacting with DynamoDB in that case in a kind of a custom home rolled solution. Okay. Looks like the typing in the chat died down a little bit. Let's talk about queuing. This is actually one of the major things I would say that is important for your integrations. And if you want to have reliable integrations that guarantee delivery, queuing is absolutely essential. So queuing is when you park messages in a message parking lot, is how I think of that. And I'll show a diagram of how that works in just a second. Ways that you can queue messages is queue providers, such as AnyPointMQ. That's MuleSoft's offering. Great offering for a queuing backbone. AWS SQS, and of course, the list goes on and on and on. Azure has queuing, RabbitMQ, again, the list goes on. Various queuing connectors provided by MuleSoft, such as VMQ as well. So VMQ is a great option if you don't want to externalize your queuing and you want to be able to build very quickly. You can use VMQs right away, and that will use MuleSoft's out-of-the-box implementation. When to queue messages, it's great for asynchronous invocations. It's great for metering and throttling before a downstream system so you don't flood that system. And checkpoints to guarantee delivery. So I'm going to talk about that one quite a bit, except I'll talk about it in the benefits of queuing messages. When it's not a good idea to queue messages is when you have synchronous invocations. So if you expect a response from a target system, you can't necessarily, there's ways probably to home roll this, but you can't necessarily expect to queue a message and then check on that message at a later time, because once that message is in the queue, it's going to process downstream asynchronously for the most part, unless you do something pretty intelligent. And then live event streaming. So queues are meant to be a parking lot. So look at that first row up there, right? I use parking lot for a reason. They can get backed up. Parking lots can get backed up. They're a holding place, right? So if you want to do live event streaming, queues are probably not the best option for you, because you can have backups in those queues. You can have 1 minute backups, you can have 10-minute backups. I've seen 3-hour plus backups in a queue, and that's totally expected and totally fine. And then the benefits of queuing. So 0 data loss. This is part of what MuleSoft preaches as the reliability pattern. So under point 1 and 2 here. The reliability pattern ensures that when you queue a message, that it's going to make it to the target. So if you have any checkpoints in your system where you have data loss, it's probably a good candidate to insert a queue at that checkpoint, because what you can start to do with that queue is cycle messages through that queue. You can start to implement a DL queue, which is a dead letter queue. And that dead letter queue will ensure that even if you can't process a message, let's say 3 times over, 5 times over, after 5 retries, you can send that to a dead letter queue to never actually lose that message, and then maybe manually process that message after it hits the dead letter queue, alert after it hits the dead letter queue, and we'll take a look at how that works in a minute. And then decoupling application components. So if you want to have one application operating completely separately from another application, a queue is a great thing to stick in between those applications, because errors in one application will be totally isolated from errors in another application. This is how queuing works. Pretty simple. Imagine the queue again as a message parking lot. When a message comes in, what it's going to do is land in that parking lot. in general, queuing is first in, first out, and you can actually ensure first in, first out with certain queues. But in general, just know that it's about first in, first out, but not always guaranteed. And then you can dequeue those messages on the other side. So what happens is a system might pump in messages into a queue, and then on the other side of that, you're grabbing those messages from that queue to be able to process them. If you can't process them, that message can just stay in that queue or go to a dead letter queue. And so how we're implementing that for our example, zoning in on the 2 queues here, the most prevalent example of this in this system is the bottom yellow box. So I've talked about logging a little bit here, and what we're doing with the queue on the bottom here, the logging queue, is in our experience API, in our system API, we're sending logs to this logging queue. We're asynchronously eventing those logs out to just be handled by our logging framework. And so what this logging queue does, again, it's just a parking lot for our log messages. And what our logging microservice can do here is just look at that queue and start to churn through that queue as fast as it possibly can to be able to send those logs out to an external system. And we'll talk more about that, what that external system is in just a little bit. But know that that queue is guaranteeing the delivery of those log messages as long as it can make it to that queue. Okay, next, along with queues, usually comes decoupling. So I had to talk about decoupling here. And with decoupling, what you're doing is you're keeping parts of a system totally separate and isolated. It doesn't get much more complicated than that. What you want is one system. If it's failing, you want that to be totally isolated from the other components of your system. Great use case for decoupling. So when you logically split your application components into microservices, that's a great way to decouple. If you have a monolithic application, let's say running on 4 vCores in Cloud Hub, probably a good idea to start to look at the different components of that system and decouple it into a more microservices approach. And then using queues in between those application components. So as you maybe break up that monolith, you can use queues in between those different application components to still allow them to talk to each other. And when to decouple, again, I've already mentioned monolithic applications. Failures that occur that should not affect other areas of the system. And I've seen this plenty of times where, for example, let's say you have an FTP outbound endpoint and your FTP outbound system or server, I should say, is totally down. And that's affecting your inbound endpoints. And you can't actually ingest data now because of your FTP outbound endpoint. Probably a good idea to take a look at those and decouple those into separate microservices so that they can operate on their own. When there's too many vCores that are needed to maintain one application, so let's say maybe you've gone up from 0.2 vCores to 1 vCore up to 2 vCores and then so on and so forth, vertically scaling your applications, probably a good idea to take a look at decoupling that into smaller units of work. And then when scaling one application is difficult, I like to shoot for horizontal scaling here instead of vertical scaling. And when you really decouple into microservices, you get that great benefit of being able to scale horizontally. So, let's say 2 applications, 2 mirrored applications at 0.1 vCore rather than 1 application at 1 vCore. When it's not a good idea to decouple, when you have a microservice that's already small enough. So I've gone around and around on this many times when you kind of debate whether something is already small enough or not. If you think it's small enough, it probably is small enough. You don't need to decouple it further. And then a microservice already performs one function well. So let's say you have an application running Cloud Hub already at 0.1 vCore and it's doing its job and it's never broken, you never need to scale it. It's probably not a good candidate to decouple because it's already doing its job. Benefits of decoupling, like I've said a couple times now, errors are totally isolated in your individual application components. And then you can fine tune each component of a system. And that's kind of what I was talking about in terms of breaking, let's say, FTP outbound up from API inbound endpoints. Your FTP outbound now can scale horizontally, vertically, however you need to do that, totally separate from your API inbound endpoints. This is what decoupling a system might look like. So one downfall to decoupling the system is that you have more applications to manage throughout your system, but I truly believe the benefits outweigh the downfalls here. And you want to be able to be sure that each one of these components don't affect one another. So you don't have a decoupled application necessarily. Let's say if on the right-hand side, your order history API depends on your orders API. If those two affect one another and don't have isolated error handling frameworks, isolated logging frameworks, and so on and so forth, they're still going to be somewhat coupled, even though they're separate applications. So you have to think about that in a distributed system like this. And decoupling a system with messaging, what that might look like is you're going to have producers and then a queue in the middle and then consumers on the other side. And that's exactly what we've done with our logging framework, where your consumers can operate and pull messages from your queue completely separately from your producers putting messages onto that queue. The decoupling example. So we're looking at this system data flow architecture diagram here in a few different ways. So now the decoupling example means that I think the most prevalent example is, again, down the bottom right, our logging microservice. Our logging microservice, if you look at the second step there, after it receives an SQS message, it's going to look for a transaction ID. And if the transaction ID is null, it's going to throw an error. And that error would never get propagated back to our experience API or our system API. It's isolated to that application. And we can throw that error and be able to, have our own error handling framework from within that logging microservice. But it's just going to move on to the next message and the next message and the next message, not affecting the upstream application. So having this logging microservice has a bunch of benefits, and that's achieved with the queue in front of it. So let's break this up a little bit more. We're going to talk about throttling next. In the chat, can anyone name 2 use cases for throttling? Anyone? Yeah, usage limit, yep. Downstream system not accepting integration's pace, absolutely. Back pressure, exactly. I think everyone's hinting at them. So I came up with a few use cases here. And first, let's just define throttling for anyone that doesn't know. I hear rate limiting and throttling getting mixed up quite a bit. So just to define rate limiting really fast, which we're actually not going to talk about today, is when you rate limit, you're actually giving somebody a hard cutoff. So let's say your rate limit is 2 requests per second into your system. After 2 requests per second, you would start to return error codes back to your client. Your client cannot exceed 2 requests per second. Throttling, on the other hand, can be set at 2 requests per second. But after 2 requests per second, what's going to happen is you're going to slow down any subsequent requests. So if your throttle is set at 2 requests per second and you go to 4 requests per second, 2 out of those 4 requests would be delayed. And so throttling, at its basic, in its basic form, is limiting the number of concurrent events at any one time. And ways to throttle, there's a bunch actually in MuleSoft, is you can limit the max concurrency on a flow in Mule 4. You can use a processing strategy in Mule 3. You can use queues. You can use holding locations like a database as well. And when to throttle, you can, if you have the potential to flood a downstream system, I see this with databases all the time, where you want to go and open 200 concurrent requests to a database, and that database can only handle 50 concurrent connections at any one time. You're going to flood that downstream database. You might run into locks even on that database. So you have potential to flood that downstream system. Throttling is a great use case. If you want to delay processing of data for any reason, you might put it in this holding location to be able to throttle it. And then control application utilization. So I see this one overlooked quite a bit. If you say, know that you're going to, like for a logging framework, for example, receive millions of messages per day, and you don't care how fast those are actually logged into the target logging system, you can control your application utilization by throttling the number of messages that you process at any one time to not be able to use the memory, all of the memory and CPU on that particular application. So maybe you control it just to 30 concurrent messages at any one time, and your queue is there to just back up, and so you can churn through those logging messages When it's not a good idea to throttle, your system cannot process data fast enough, or when your downstream systems can handle your volume. When your downstream systems can handle your volume, I would say floodgates are open, right? You can process as fast as you possibly want. And the benefits of throttling. So you can control the number of concurrent events. You get more fine-grained control of your application's utilization. And you can protect against system flooding. So throttling, this is going to be kind of the last component that we're talking about here in terms of integration best practices. Throttling can occur again on a database, I believe, is a great use case. So when we talked about our asynchronous flow here, we're kind of zooming into the top right of that data flow diagram. When I have a post request looking to insert information into my database, I can throttle now with the queue in front of it the max number of messages that I pick up from that queue at any one time so that I don't flood my downstream database. Okay, so let's demo all of that. So I'm going to pull up actually AWS here. So we're first going to talk about AWS SQS. And this is not a lesson on AWS. We're here to talk about MuleSoft. If you want to talk more about AWS, feel free to contact me after this. But what we're doing with that logging queue, as I was talking about, is we've stood up an AWS SQS queue, and I mentioned a DL queue earlier also. DL queue, again, stands for dead letter queue, and what you're able to do with AWS SQS, as well as many other common queue frameworks, is create a connection between a queue and a dead letter queue. And with AWS, the way you do that is a redrive policy. And so what I'm basically saying here in plain English is all of my messages being sent to my logging queue here basically have 2 iterations to go through that queue. So they can retry 2 different times to try to make it to the target logging system. If it fails more than 2 times, what's going to happen is the queuing backbone is automatically going to send the message to the Mule logging DL queue, which lives right here. And what we can do on the Mule logging DL queue, there's a bunch of different things that you can do here. You can stand up a system to be able to pull messages from this queue and maybe alert on them. You can, by default in AWS, alert on any messages that land in this queue. You can create business processes off of these DL queues. For example, maybe it's a manual intervention that needs to occur whenever a message hits a DL queue. There's numerous different things that you can do. But what this allows you to do is decouple your application components. So my system API and my experience API are decoupled from my logging application. And I'm guaranteeing with the use of this queue and the DL queue that my logs actually make it to my target system. And if they don't, they're persisted somewhere. That's key. We're never losing that data. They'll always land somewhere. So let's talk about decoupling a little bit. And what I can do here is cheat just a little bit. If I send a test message to my logging queue, and so let's let that process for just 1 second. I'm going to go back to the PowerPoint really quickly. And what you're going to see with the logging framework, again, just as a reminder, is if the transaction ID is null, it's going to throw an error, right? So what we're going to see with that message that I just sent to that logging queue is it should cycle through that queue a couple of times, as we're going to check in the logs here in just a second. And when it's done cycling through that queue, it'll land in the DL queue automatically with no extra code. So let me show the code really fast while that's processing. And this application is absolutely dead simple. It is this one flow, and that's it. You have a logging framework here. And to be fair, it's not a full logging framework. There's no exception handling, kind of nothing like that. But with this simple of a flow, we're guaranteeing, like I said, delivery of that message. We've implemented MuleSoft's reliability pattern, and we will never lose that data. So all this is doing is transforming the message into JSON. It's going to validate the transaction ID is not null. It'll do some logging of its own, and then it'll delete the message off that queue. So when it's done successfully processing that message, it will take the message off that queue, and that's how it will know never to process that message again. But only on success, it'll delete the message from that queue. So dead simple flow. So let's take a look at UniPoint here. And we're gonna go to our logging application. And in our logging application, what I would expect to see is a couple of errors. And it looks like this just occurred a couple minutes ago. What you see here is this test message coming through here, and automatically, without any additional code, it's cycling through here a couple of times, because on this error, it's all that message is doing is it's staying on the queue. And then a few seconds later, we're gonna try to process that again. And on that second attempt, what we're saying is now, through the use of those SQS queues, go put that message in that DL queue. And so let's just make sure that it made it to that DL queue. So if I refresh here, we can see the DL queue here. And again, we could have alerted on this. If I view the message in this queue, it's not gone anywhere, right? We have now, with SQS specifically, we have 14 days to be able to pick up this message from the queue. It's always in this landing zone. And finally, let's talk about throttling, was the last piece there. So I'm gonna start in API Manager. And in API Manager, what you can do, I listed the few ways to throttle on the throttling slide, is you can implement something called spike control. So this was called, it was called throttling in Mule 3. It's called spike control in Mule 4. And what you can do is start to limit the number of requests per time period. And so, for example, what I'm doing to this system API is I'm limiting 10 requests per a period of 1,000 milliseconds. So that's 10 requests per 1 second. If I exceed 10 requests per second, I'm not going to error out. I'm only going to start to delay those messages that go beyond 10 requests per second. And the other way that I can do this, let's go back into our system API here. Actually, it's this one. In the system API, again, something that's dead simple that you can implement with the API manager policies and the max concurrency in MuleSoft. Again, you don't have to implement both of these. They're only going to be right when they're right for you. But to limit the number of max messages that you pull from an inbound endpoint, or just to limit the number of concurrent threads that a flow has at any one time, what you can do is use this max concurrency box on a flow. That's simple. All right, so those are the couple ways to throttle. We talked about decoupling and queuing. Just looking in the chat box, see if there's anything that stands out. I think we can, there's only a little bit left in the presentation, so we can get through there and then answer any questions. So logging, I think, is the last piece of the puzzle. No good system is complete without logging. You get the visibility and traceability and decrease support costs if you have a good logging framework in your system, especially if you have distributed microservices. So logging. What is logging? You're exposing system events to gain visibility and traceability in your system. So almost every client I've ever interacted with has had problems with logging and has even lost logging messages in the past. And when you lose logging messages, you can think about the impact of that is you're sort of dead in the water. You know, you don't know what happened to that transaction. So you want to guarantee the delivery of those logging messages with the reliability pattern that we just talked about. Ways to log and monitor. You can log to an external system, such as Elk or Splunk. I would highly recommend this. When you log to an external system, what you get is the ability to log to one central location from all of your distributed applications. You can log in Cloud Hub, which we just looked at. You can log to a file. You can log to a database. And again, the list goes on and on and on here. I didn't list all the options, but my favorite and preferred option is logging to some sort of logging system like Elk or Splunk. When you should log and monitor, so you want to take a step back and not overlog. You don't want to underlog, and this is a whole subject on its own. You want to log at logical events within your system where it's right for you. So think about checkpoints in your system. So maybe it's before and after a database call. Maybe it's before and after an API request. Maybe it's when you receive an API request. And you want that event to tell a part of a story. So you want to be able to connect events that occur throughout your system. So if event A, B, and C occurs in your system, 3 distinct steps in a process, you probably want to log at each one of those occurrences. When it's not a good idea to log, if you're already overwhelmed with logs, I would actually look at reducing your logs probably, just to tell a concise, neat story of what occurs in the system. And then pertinent information is not captured. So for example, right when you receive an API request in MuleSoft, you may not have all the information that you want. For example, I'm creating a transaction ID, and maybe I save that payload to S3 after I receive that API request. Maybe I want to wait to log my first log until after my transaction ID is created and after I persist to S3, maybe. And then the benefits of logging and monitoring is increased visibility into the system, of course, trace transactions from end to end, you can tell that story, and then decrease support cost, which all organizations are after. And logging. So now the final angle that we're going to talk about here. Didn't realize it wasn't in presentation mode there, but just to blow this up so you can see it. The logging framework, which I've already talked about, receives SQS messages from the queue, identifies that the transaction ID is null, and if it is, it throws an error. And if not, it will use log4j2 to send those logs out to Elk and Splunk. And so we're going to take a look at Splunk here in just a second. But the pertinent information that you have to look at here is each one of the logs coming from our system has a transaction ID associated with it. And that transaction ID is the same for one particular API request across all 3 of our applications. If it was different, I wouldn't be able to tell the story of the events that occurred within the system. So let's take a look at that. So I'm going to use this transaction ID here and log into Splunk. And in Splunk, what I can do, again, I'm not going to talk too much about these logging systems, but if anyone's curious, happy to talk after this or offline. What I can do in Splunk is, since all of my logs were persisted to Splunk, the centralized external system, what I can do is start to tell a story of what actually occurred for that particular insert. So I believe I was inserting Aaron in that case. And so what I can do there based on this transaction ID is I can say I received an inbound request. I received an inbound post request, to be specific, and I'm sending that to my SQS queue. So that would be from my Experience API. And then what I'm going to do is, it looks like, okay, now my system API has picked this up. And so across those 2 distributed applications, you can see by the flow here, what I'm doing is I'm getting, I'm inserting that Pokemon into the database now in my second application. And then finally, I've inserted that Pokemon into the database. All right, cool. That happened totally asynchronously for me on the front end here with Postman. But on the back end now, as a user, maybe of the system, or as a support employee supporting the system, I can come in and easily input that transaction ID to be able to tell exactly what happened in the system here. And then very quickly, what I can do in that logging application to make this all happen, if you remember this logging application, it was dead simple. And really all we have is this single logger here. This one logger takes care of logging to all these external systems. So this actually logs to Splunk, it logs to Cloud Hub, it logs to a local file, and it logs to Elk. And that's all made possible by the use of log4j2. So again, this is another whole subject on its own here, so I'm not going to get too deep into this. But what you can take away from this is that the appenders here are responsible for logging to those different target systems. And so what you have here, this rolling file, this is logging to a local file. Gelf here is logging to this particular host, which is our Elk host. Splunk is reaching out via HTTP to our Splunk instance right here. And SQS, I can also log to a different SQS queue. I'm not doing this because I just received a message from an SQS queue. But you can see here that you can actually vent out to another SQS queue from log4j2 if you wanted to. And then log4j2 Cloud Hub appender. So this allows you to log to Cloud Hub which I'll show here. So in this logging application, one nuance for your log4j2 configuration to take over is you disable these Cloud Hub logs. So when I check that, what you get here is that kind of this warning, right? Cloud Hub logs have been disabled, and MuleSoft is kind of warning you that you better know what you're doing here and have the right logging in place in that log4j2 configuration. So I highly suggest to test that first before you use it. But since my Cloud Hub logging is disabled, that log4j2 configuration is taken over. But what looks exactly the same here is just like any other logger. That logger is using that log4j2 configuration to write logs to Cloud Hub here. It's writing those logs to Splunk and all of those other different locations that I just talked about. So that one log4j2 configuration is asynchronously venting out to multiple different target systems. And finally, let's start from this slide. We're wrapping up. As summary, can you name 2 use cases for a synchronous API and 2 use cases for an asynchronous API in the chat? And you can even go off of the demo that we just had there. So maybe think about that for the chat. And just to wrap this up, what you get here from just 3 applications and 2 queues is so many different components here and so many different integration best practices. You get the synchronous versus asynchronous, queuing, throttling, application decoupling, guaranteed delivery, and that reliability pattern, caching. So think about, all I did here was create 3 pretty simple applications. So think about that for your systems. And again, feel free to reach out to me or anyone at Big Compass to be able to talk about this more. These are fairly simple integration best practices that will take you to that next level for your integrations. And so I have a bunch of references and documentation here. Again, I will send out this presentation either tonight or tomorrow to everyone who RSVP'd, as well as the recording here. Feel free to dive into those. And I will take questions at this time. And actually, before I do that, if you have a topic that you're dying to hear about, number 1, if you could put that in the chat. I would love to take down any subjects that we can present on in the future. Number 2, we are looking for presenters. We will always be looking for presenters. If you ever want to present at the Denver MuleSoft meetup, contact me or Linda or Brian. I actually didn't put Brian's email address there, but you can contact me or Linda for now if you are interested in presenting. Thank you all very much for joining. Our next meetup will probably be in either July or August. The date is to be determined. It probably will be a virtual meetup again. So again, thank you all very much. And at this point, I will take any questions you have. All right, so I probably have to scroll back up the list here. Linda, if you've inventoried any of these?
You know, most of them, they're answering their each other's questions.
Great.
So I'd go with that last one.
Last one. Starting with we are getting?
Yeah. Mm-hmm.
Okay, so we are getting more clients who want to do ETL-like apps in MuleSoft. I'd like to see some best practices around batch processing and large data volumes. Yeah, so I think that's a suggestion for a different topic, it sounds like. But absolutely. And Tom, just to address that very quickly, you know, what you can do with the reliability pattern is it absolutely pertains to processing large batches and large amounts of data. You know, with that reliability pattern, let's say you get you know, many messages into your system at once. What you can do is use those integration best practices, you know, throttling, for example. You can use queuing and decoupling of your applications to be able to churn through all of those concurrent requests or that batch process. But I agree, we should dive into that more. Okay. I don't believe that's a question. I believe that's a suggestion. ETL gets strong challenge with Talend. Yep. So ETL could be a great subject. You know, Brian, we can maybe chat about that next time.
Sure. Aaron, there was one question I found. Somebody asked, when do we configure deadlighter queue in application? Is it inside error handling?
It is not actually. So with your queuing backbone, and so I'm talking about AWS here specifically, but with most queuing backbones, they're going to have this capability where you can set up your dead letter queue, and within that queuing backbone, just being totally configuration driven with no code whatsoever, you can send messages to that dead letter queue after the specified number of retry attempts.
So you're basically saying that's the message or queuing system configuration as opposed to a coding
system
exercise.
Yep.
Okay.
Codeless. Is there any way we can set the logging level on deployed apps in Runtime Fabric? I know we can get different packages in Cloud Hub, deployed app, and see the logs without changing the application. The big question is, can we set the logging level on deployed apps in Runtime Fabric? I would have to check. I believe you can, because in Runtime Fabric, and actually I have one here. Still deployed. They're not, but yeah, it's something I can get back on. Good question. So from Mike, is your log4j config in the experience and system API just using SQS as an appender? Yes, exactly right, Mike. SQS is just being used as an appender. And that's from our logging application. To actually get those messages into the queue, into the logging application, they're actually using an explicit send message from the MuleSoft code. Okay. Anything else?
Aaron, I'm just curious, you didn't cover it tonight. Have you ever had to deal with message ordering, especially across a cluster? Make sure messages are processed in order from the FIFO queue.
I have, and it's not an easy challenge. So number one, it becomes easier when you don't have a cluster, right? You can use a FIFO queue, for example. But if you don't have a FIFO queue to be able to handle this, what you can do is think about a staging location. And there's systems built like Apache Kafka, for example, that are tailor-made to do this because it is not an easy challenge. But what you can do is use that staging location, maybe use timestamps to be able to achieve that order delivery. I know that's vague, but it's kind of dependent on on the actual scenario. Brian, anything else you would add to that?
You're right. It's a challenge across a cluster, and yes, you have to have some sort of your correlation or some sort of timestamp just to make sure that you don't process them out of order. I remember some of the on-premise systems did have some built-in capabilities to their messaging subsystem to kind of handle that, but yeah, it was always a trick.
Yeah, I see the component of probably queuing at play there, probably throttling, probably decoupled application components. Using quite a few of the integration best practices. Anything else from anyone? Otherwise, we can say till next time. Okay, like I said, don't hesitate to reach out.
Thank you, everybody. Thank you so much.
Yeah, thanks a lot, Aaron.
Thank you, everyone.
Have a great night, everybody.
Have a good night.